Hello friends, welcome to i-TUTOR NCERT series. Today we are going to discuss Class 6th Geography NCERT second chapter Globe, Latitudes and Longitudes. Let's start. Our planet Earth is not a sphere. It is slightly flattened at the north and the south poles and bulged in the middle. So we know what is the shape of our Earth. It's geoid shape. Okay, it's a geoid shape. So it's not circular or it's not sphere. It's a geoid shape. So it's slightly flattened at the north and south poles and bulge in the middle. Now, what is globe? Globe is a true model or miniature form of Earth. So, globe is a true model or miniature form of Earth. Globes may be of varying size and type. Big ones which cannot be carried easily, small pocket globes and globe-like balloons which can be inflated and are handy and carried with ease. The globe is not fixed. It can be rotated the same way as the top spin or a potter's wheels is rotated. On the globe, countries, continents and oceans are shown in their correct size. So, it's a small description about globe. So, this is simple fact. We all know what is globe and what is the shape of Earth. So, it's normal or common facts. Now, moving forward, a needle is fixed through the globe in a tilted manner, which is called its axis. Okay, so we can see, look at here, this is a globe and look at this is a needle. Okay, it's a needle. A needle is fixed through the globe in a tilted manner, which is called its axis. So what is this? It is axis. Okay, this is axis of globe. So this is the axis of globe. 2 points on the globe through which the needle passes are 2 poles, that is North Pole and South Poles. Look, this is North Pole. Okay, the 2 poles. First one is North Pole and this is South Pole. Okay, let's denote it as S and N. So the 2 points on the globe through which the needle passes. Look, this needle passes through 2 points, that is North and South. The globe can be moved around this needle from west to east, just as the Earth moves. So we can move this globe from west to east, just like the Earth moves. So this is globe and it has 2 points, that is north and south points. Then this is called axis and we can rotate this from west to east, just like the Earth moves. But remember, there is a major difference. The real Earth has no such needle. It moves around its axis, which is an imaginary line. So we know what Earth has an imaginary line, that is called its axis. Okay. Now, an imaginary line running on the globe divides it into 2 equal parts. This line is known as equator. Okay, so equator, this is important. An imaginary line running on the globe divides it into 2 equal parts. Look at this picture. This is a globe or this is a form of Earth and this line, this imaginary line is called equator. So what happened? This imaginary line divides Earth into 2 equal parts. Okay, look. This is our Earth. Assume it as Earth and there's an imaginary line. Okay, so this imaginary line, this divides Earth into 2 equal parts and this part is known as northern hemisphere. So this is north part. So it is known as northern hemisphere. And this part, okay, this circle parts, this part, this is known as southern hemisphere. Okay, the south part is known as southern hemisphere. So the northern half of the Earth is known as northern hemisphere and the southern half of the Earth is known as southern hemisphere. They are both equal halves. Therefore, the equator is an imaginary circular line and is a very important reference point to locate places on the Earth. All parallel circles from the equator up to the poles are called parallels of latitude. So, look at this. This is equator and these lines. So, all lines, these lines, okay, these are called parallels of latitudes. Okay, and this is measured in degrees. Okay, these lines are called parallels of latitudes and this is measured in degrees. So this symbol, what an imaginary line that divides Earth into two equal parts, that is called that imaginary line is called equator, and the north part is called the northern hemisphere and the southern part is called southern hemisphere. And all the lines, that all the imaginary circular line is called, or all these circles from the equator up to the poles are called parallels of latitudes. Parallels of latitudes, and these are measured in degrees. These parallels of latitudes are measured in degrees. So this is equator and other parallels of latitudes. Now the equator represents the 0-degree latitude. So we know what the equator represents, 0-degree latitude. So it's 0 degree. This is 0 degree. Equator is always 0 degree. 0-degree latitude is called equator. Since the distance from the equator to either of the poles is 1/4 of a circle round the Earth, it will measure 1/4 of 360 degrees. Okay, so if we calculate the distance from the equator to either of the poles is 1/4 of the circle around the Earth. Okay, so we calculate it as total 360 and it's 1/4, that is 90 degree. Okay, so 90 degree. Thus the 90 degrees north latitudes mark the North Pole and 90 degrees south latitude mark the South Pole. So this is this point, this North Pole, this is 90 degree north and this point is 90 degree south. Okay, so I hope you understand. Now as such, all parallels north of the equator are called north latitudes. Similarly, all parallels south of the equator are called south latitudes. So all the parallels north of the equator are called north parallel and all the parallels south of the equator are called south parallel. South latitudes. North latitudes and south latitudes. The value of each latitude is therefore followed by either the word north or south. Generally, this is indicated by the letter N or S. For example, both Chandrapur in Maharashtra and Belo Horizonte in Brazil. Okay, these both are located in the parallels about 20 degree latitudes. So this Chandrapur in Maharashtra and Belo Horizonte in Brazil, these both are located in the same latitude, that is 20 degree. But first one, that is the former, the Chandrapur, this is located in 20 degree north latitude. Okay, so this is located in 20 degree north latitude and this is located in 20 degree south latitude. Chandrapur located in 20 degree north latitude and Belo Horizonte is located in 20 degree south latitude. Okay. Now, as we move away from the equator, the size of the parallels of latitude decreases. Look, this is Earth and this is equator. Okay, 0 degree equator. As we move away from the equator, to both sides, that is south and north, what happened? The size of the parallels of latitude decreases. Look at this size, it's decreasing. Okay, the poles it's very small. Okay, so as we move from the equator, the size of the parallels of latitude decreases. Okay, now important parallels of latitudes. Okay, now let's check what are the important parallels or latitudes, parallels of latitudes. We know the first one is equator. Look at this 0 degree. Okay, the 0 degree latitude, it is called equator. The North Pole and South Pole, that is 20 degree, 90 degree north and 90 degree south. Look at this here, 90 degree north and 90 degree south. North and south latitudes. Now, this line, that is 23.5 degree north. 23.5 degree north. This is called Tropic of Cancer. This is called Tropic of Cancer, 23.5 degree north in the northern hemisphere. And same 23.5 degrees south in the southern hemisphere is called Tropic of Capricorn. This is called Tropic of Capricorn. Okay, then Tropic of Cancer and the Tropic of Capricorn, 23.5 degree south. Next, Arctic Circle and Antarctic Circle. In 66.5 degree, look at this, 66.5 degree north, it's called Arctic Circle, and 66.5 degree south, it's called Antarctic Circle. Now, heat zones of the Earth. The midday sun is exactly overhead at least once a year on all latitudes in between the Tropic of Cancer and the Tropic of Capricorn. So, in midday sun is exactly overhead at least once a year on all latitudes in between. Look, Tropic of Cancer. This is Tropic of Cancer and this is Tropic of Cancer. Capricorn. So, the midday sun is exactly overhead at least once a year on all latitudes in between the Tropic of Cancer and Tropic of all latitudes. Okay, so there are so many latitudes between Tropic of Cancer and Tropic of Capricorn. So at least once a time or once a year, all the midday sun is exactly overhead all latitudes between the Tropic of Cancer and the Tropic of Capricorn. So this area therefore receives the maximum heat, and this area is called torrid zone. Okay, so the area between 23.5 degree north and 23.5 degree south. This area, the area between 23.5 degree north and 23.5 degree south, this area is called torrid zone. Okay, this area is called torrid zone. Now, the midday sun never shines overhead on any latitudes beyond the Tropic of Cancer and the Tropic of Capricorn. The angles of sun's rays goes on decreasing towards the poles. Look, so let's assume now the sun is in this portion, sun is in this portion. Okay, the sun rays are directly falling on this area, that is the torrid zone. But moving from the torrid zone, look at this, the distance is increasing. Distance from the sun to the portion is increasing. So what happened? The sun rays goes on decreasing towards the poles. Okay, so the sun rays or the angle of sun rays goes on decreasing towards the poles. As such, the areas beyond area bounded by Tropic of Cancer and Arctic Circle in Northern Hemisphere. Look, this portion between Arctic Circle and Tropic of Cancer and in Northern Hemisphere, and Tropic of Capricorn and the Antarctic Circle in the Southern Hemisphere. Look, Tropic of Capricorn and Antarctic Circle between this area in the Southern Hemisphere. These areas have moderate temperature. Therefore, this area is called temperate zone. Okay, so these two areas, that is in Northern Hemisphere between Arctic Circle and 23.5 degree between Arctic Circle and Tropic of Cancer. Here between Antarctic Circle and Tropic of Capricorn. Okay, so this area, this shaded area, this is known as temperate zone. This area is known as temperate zone. Okay, now look at the last zone, that is called frigid zone. Okay, as the name mentioned, it's also freeze. Okay, the area was very freeze because of the low amount of sun rays. Look, areas lying between the Arctic Circle and the North Pole in the Northern Hemisphere and Antarctic Circle and the South Pole in the Southern Hemisphere are very cold. This area, this blue area, that is between Arctic Circle and North Pole, Antarctic Circle and South Pole. So this area is very cold. It's because here the sun does not rise much above the horizon. Therefore, its rays are always slanting and provide less heat. Therefore, these are called frigid zones. So this place or this portion is called a frigid zone. Okay. So we already discussed about latitudes. Now, what are longitudes? To fix the position of a place, it is necessary to know something more than the latitude of that place. You can see, for example, that the Tonga Island in Pacific Ocean and Mauritius Island in Indian Ocean are situated on the same latitude, that is 20 degrees south. Okay, so look at this picture. This is equator and this is 20 degree, this is 20 degree latitude. Okay, 20 degrees south latitude. So both Mauritius Island and Tonga Islands, so both of these islands are situated in the same latitude. Okay, both Tonga Islands and Mauritius Island are situated in the 20 degrees south latitudes. So it's very hard to find this place, or very difficult to find this place. So we must find out how far east or west of this place. So we have to find how far east or west of this place. And the distance between them are measured in degrees of longitude. Okay, so the distance between them are measured in degrees of longitude. Each degree is further divided into minutes and minutes into seconds. Okay, they are semicircles and the distance between them decreases steadily polewards until it becomes 0 at the poles. Look at this picture. This is 1 degree of longitude. Okay, this is 1 degree of longitude and this is another. Okay, look at this picture. We can see that from poles, okay, from the middle to the poles, okay, to both the poles. What happened? The distance between these two lines, or the distance between these two longitudes are decreasing. Look at the distance is decreasing. Okay, distance between these two longitudes are decreasing. Okay, they decreasing steadily polewards until it becomes 0 at the poles. So in this pole area, what is the distance? This is 0. Okay, because all the degrees of longitudes are meet at this point. So this is 0. Okay, so there is 0. Now, unlike parallels of latitude, all meridians are of equal length. So all these meridians, all these degrees of longitude, all these longitudes are same length. Okay, so these all are in same length. But in the case of parallels of latitude, what happens? From equator to poles, the length or the what happened? The length decreases. Okay, in the case of latitudes. But in the case of longitude, what happened? They are equal length. They are equal length. Thus it was difficult to number the meridians. Hence, all countries decided that the count should begin from the meridian which passed through Greenwich, where the British Royal Observatory is located. So all countries decided that the count should begin from the meridian which passes through Greenwich, that is where British Royal Observatory is located. This meridian is called prime meridian. Okay, so this meridian is called prime meridian and its value is 0 degree longitude, and from it we count 180 degree eastward and as well as 180 degree westward. Okay, so look at this line. This is called, this dotted line is called a prime meridian. Okay, so this is called a prime meridian and this is 0 degree longitude. This prime meridian is 0 degree longitude, and from this meridian, from this prime meridian, we count 180 degree eastward as well as 180 degree westward. Okay, so we count 180 degree eastward and 180 degree westward. From here 15, 30, 45, etc, 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 180 degree east, and the same here 180 degree west. Okay, the prime meridian 180 degree meridian divide the earth into two equal halves. Look, the prime meridian and 180 degree meridian, look, this divide earth into two equal halves, the eastern hemisphere and the western hemisphere. Look at this, the equator divide earth into two parts, that is northern hemisphere and southern hemisphere. Like here the prime meridian and 180 degree, this is prime meridian and just opposite here. Okay, this is 180 degree meridian. This is an image that we can't see here because it's not a 3D image. So this line, so these lines divide earth into two equal halves, that is eastern hemisphere and western hemisphere. Okay, therefore the longitude of a place is followed by the letter E for the east and W for the west. It is, however, interesting to note that the 180-degree east and 180-degree west meridians are on the same line. Okay, so 180-degree east and 180-degree west meridians are on this same line. Okay, both are seen in this same line. Okay, look, this dotted line is called a prime meridian. Sorry, okay, this is called prime meridian, and just opposite to this line, this is 180-degree east and 180-degree west. Okay, so these two are in same line. Dhubri in Assam is situated at 26-degree north latitudes and 90-degree east longitude. Okay, so this is easy to find this. Okay, 26-degree north latitude and 90-degree east longitude. So we have the 2 point, and when these 2 points are intersect at a point, that is, this place is known as Dhubri. Okay, this is Dhubri in Assam. So that's all about the longitude. Now, longitude and time. The best means of measuring time is by the movement of the Earth, the Moon and the planets. The Sun regularly rises and sets every day, and naturally it is the best timekeeper throughout the world. Local time can be reckoned by the shadow cast by the Sun, which is the shortest at noon and longest at sunrise and sunset. When the prime meridian of Greenwich has the Sun at the highest point in the sky, all the places along this meridian will have midday or noon. As the Earth rotates from west to east, those places east of Greenwich will be ahead of Greenwich time, and those to the west will be behind it. Okay, so as the Earth rotates from west to east, we know Earth is rotating from west to east. So those places east of the Greenwich, this is our Greenwich. Okay, this dotted line is known as Greenwich, that is 0 degree. Okay, so this line. So the place east of Greenwich will be ahead of Greenwich time. Okay, so here this place, the place east of Greenwich will be, this place east of Greenwich will be ahead of Greenwich time, and the place west of Greenwich will be before or behind it. Okay, now look at this. There are different can be calculated as follow. Okay, the Earth rotates 360 degree in about 24 hours. Okay, so we know the Earth rotates 360 degree. Okay, the Earth rotates 360 degree in 24 hours, which means 15 hours for an hour. Okay, 15 hours, 15 degree an hour. Okay, so in 24 hours it's 360 degree. So in 1 degree it take, in 15 degree it take 1 hour. So for 1 degree it takes 4 minutes. Okay, how? Because 1 hour is 60 minutes. So 60 by 15, 60 by 15, that is 4. So 1 degree it needs 4 minutes. Okay, so thus when it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 into 4. Okay, so look at this. This is prime meridian 0 degree, and this is east, and this is west. Now if when it is 12 degree noon at Greenwich, it's 12 degree noon at Greenwich, and this is 15 degree east. So when it is 12 noon at 12 p.m. noon at Greenwich, at the time 15 degree east of Greenwich will be, what is the difference between this? So this is 4 minutes. Okay, 15 degree means 4 minutes. So what? 15 into 4, that is 60 minutes, that is 1 hour. So what? In Greenwich or in prime meridian, what is the time? It's 12 p.m. and in this east, 15 degree east of Greenwich is now 1 p.m. because it's 1 hour ahead. Okay, so that's how this calculation going. But at 15 degree west of the Greenwich, the time will be behind the Greenwich. So what is 15 degree west? This is 15 degree west. So what is the time here? Just minus 1 hour. So here 12 p.m., here 11 p.m. Okay, so this is how we calculate the time zones. Similarly, at 180 degree, it will be midnight when it is 12 noon at Greenwich. So in Greenwich, it's 12 noon, and what happened to the other side, the 180 degree, it's 12 degree, or it's morning, or it's midnight. Okay, it's midnight 12, that is 12 a.m. Okay, so this is how we calculate the time zones. Now, standard time. What is standard time? The local time of places which are on different meridians are bound to different. For example, it will be difficult to prepare a timetable for trains which cross several longitudes. In India, for instance, there will be a difference of 1 hour and 45 minutes in the local times of Dwaraka in Gujarat and Dibrugarh in Assam. It is therefore necessary to adopt a local time of some central meridian of a country as the standard time for the country. In India, the longitude of 82.5 degree east, okay, that is 82 degree 30 minute east, is treated as the standard meridian. So the local time at the meridian is taken as the standard time for the whole country. It is known as Indian Standard Time, that is IST. So this line is passing through the Mirzapur in UP. Okay, so this is, look at this picture. So this dotted lines, this is known as IST or Indian Standard Time, and this passing through the Mirzapur. Now, a day and night cricket match between India and England had started 2 p.m. in London. This means that the match would begin at 7:30 p.m. in India and finish well into the night. Do you know what is the time difference between India and England? Let's find. India located east of Greenwich at 82 degree 30 minute east. We know our time zone is 82 degree 30 minute east. Is 5 hours and 30 minutes ahead of GMT, that is Greenwich Meridian Time. Okay, so it will be 7:30 p.m. in India when it is 2 p.m. in noon in London. So look at this. This is London, and when it's 2 p.m. Okay, 2 p.m. And what's the difference between India and London? India and London. So it's 5 hours and 30 minutes. Okay, 5 hours and 30 minutes. So when it's 2 p.m. in London, what's the time in India? It's 7:30 p.m. in India. Okay, so that's why we see the match in 7:30 p.m. Okay. Now, for example, in Russia there are many as 11 standard times. Okay, so in Russia there are 11 standard times. In India we have only one standard time, that is 82.5 degree or 82 degree 30 minutes east. Okay, so that is Indian Standard Time. But in Russia, for Russia there are 11 standard times. The earth has been divided into 24 time zones of 1 hour each. Each zones thus cover 15 degree of longitude. So the earth has been divided into 24 time zones. Okay, our earth has divided into 24 time zones. Look, this is our earth and it's divided into 24 time zones. And each zone does cover 50 degree longitude. So each of this cover 50 degree longitude. That is 1 hour. Okay, so 1 hour each. 1 hour each. Then total 24 hours. And each of this cover 15 degree. Okay, so that's all for today. If you have any doubts, please ask in the comment section. For more videos, do like, share, subscribe.